Hey, Al, Brad here with another quick video. This is a post repair video. I know I started doing some bench repair videos, or I did one so far. Found a couple issues on the bench with the lighting and a few other things. The webcam, I wanted one for the overhead and one kind of pointing at me, and I only had two, so I didn't want to keep stealing from my test bench here that you're seeing this one on. So I got another cam. I bought some like screening that goes over the lights to kind of cut down on the glare a little bit. I have to put that up still. So working on that. In the meantime, I've still got customer work that comes in the queue that I've been working through. So on the bench right now is a Robotron board set. Same customer that sent in the Stargate in the previous video. He sent them together. So I got that one all wrapped up. This one turned out to be a little more work. Had an issue with a intermittent rebooting on the MPU I had to solve, and these boards they needed the full stripped down simple green bath, and the MPU on this set is a Rev B, which from the factory has some bodge wires on the top and stuff. It just doesn't look great. And I built a little board that goes on the back to fix what that bodge was there for. And there was a few other upgrades I did to the Rev C boards that I implement on the Rev B here. So it's pretty clean. I'll go over that and talk about it a little bit, and then when we get through the boards, we'll come back and do a little gameplay and wrap it up and get them coming back to the customer. So let me switch over to my bench cam here. Okay, I think we'll do the soundboard here first since it's the closest. So here's the soundboard. Um, Again, this one was pretty rough. Got all new Molex headers, pulled the fuses, recrimped them, cleaned them, all new electrolytics on the board. There's three aluminum electrolytics that I replaced with tantalums for decoupling, one here, and one on the CPU at the top here. And then the EEPROM actually was the wrong EEPROM in it. Somebody had written joust in pin on the bottom, but it was actually from a Robotron, I think. So I had one. I make these reproduction labels on here, so I put one in. These are 2532s, which are a little harder to source these days than the 2732s, which are both 4K EEPROMs. Um, I put new heatsink compound under the 5-volt 7805 regulator and the TDA 2002 audio amplifier. Make sure all the screws are nice and tight there. Put a new bridge rectifier on. And then when I got this on the bench and started testing it, did find that the PIA was bad. We were getting no data across over to the digital analog converter. And then after I had it running, I had a few glitches, which indicated that the 6810 RAM was bad. So what I did is I cut the jumper for the 6808 CPU, which uses the external RAM, and I put in a 6802. So it's using the internal RAM instead of going out to use the 6810 here. So it's rock solid now. Here's a bag of all the parts from just these three Robotron boards here. It was pretty extensive. That white socket you can see here on the soundboard too. It had those real crummy white sockets. I'm not sure who the manufacturer was, but they don't hold up well. Just in general, a lot of parts on these boards that were pretty filthy. On the ROM board here, stripped it down, cleaned it up, pulled the blitters here, the special chips, cleaned and straightened the legs. Got a new 3M ribbon cable on it. Got all new Molex headers with the square pins in all three positions. Got new Nichicon 150 microfarad 35 volt filter caps. And then when on powering up, there was a bad ROM on here, and this turns out this was an older red label ROM set which had a few bugs and things in it. And so instead of reburning the ROM and the labels were pretty messed up, I put 2732s in here with the latest version green ROMs and put the reproduction labels on it. So it's totally up to snuff what the latest rev was, and it looks real nice. It turned out good. And then the IO board, again, this is the same one I used on that Stargate set that I went through, but it's rock solid as well. And again, he may decide to do the Robotron here first and use this board and find something else for Stargate or vice versa. So, and then over here on the MPU, again, as I mentioned, this is a Rev B. So we got the battery holder area all cleaned up. We've got a nice CR2450 on here. Coming down the line here. I was having some intermittent issues, and I did put a new crystal oscillator on here. These are 12 megahertz. I've got a ton of exactly the same as the original one. So usually if I'm having random issues, a lot of times it turns out to be clock. The clock on here starts off at 12 and gets divided down into sixes and fours and twos, and then the CPU runs at one. So any sort of timing indifferences or anything like that can cause all kinds of crazy problems. So sometimes putting a fresh crystal on, these are a little more stable than the original ones, helps out quite a bit. And then coming down the line here, I did put a new 22 microfarad capacitor axial leaded in for the soft start. And what that does is there's an RC circuit, resistor capacitor, and based on the two values of those, it provides about a 500 millisecond, half a second delay on startup. So once the power comes up and it senses, the Zener here senses that there's 5 volts present, it waits about half a second before it pulls the CPU out of reset. And that makes sure all the other ICs are nice and stable and all their little decoupling capacitors are charged and everything. So the original, that was a aluminum electrolytic, which will leak and dry out over time. So we get that in there. I also put a new ZR2 on here, the Zener diode that monitors the 5 volts. The original one was 3.9 volts. And I put a 4.7 in. And this helps if you run a switching power supply. Just in general, you know, these TTL circuits were not designed to run down that low. Like 4.7 is the threshold that on the data sheets that they don't recommend running under. So I put that on all the boards I work on, 4.7 here. And then we've got the same Nichicon filter caps here, new Molex headers in all 3 positions on the board. Pulled the decoders out, cleaned the legs, straightened them, and then put new reproduction labels on for both decoders 4 and 6. CPU got pulled, again, straightened the legs, cleaned the legs, little deoxit, put back in. I did socket the CMOS RAM here, and that way if the customer in the future wants to go and put an NV RAM module in, or if the CMOS itself fails, it's just a quick swap out, not a big deal. Back here on the RAM, there was, I think, 3 or 4 pieces of RAM that were missing when it was sent in, so I've got those in. I pulled all the other ones out, cleaned them, got them kind of organized by manufacturer. There's a couple different brands on here. There's some AMD parts and some TI parts over here, but it worked real well. Again, with the intermittent problem on here, I ended up finding a 74153, which is like a multiplexer that's used for the DRAM for address decoding. So got that sorted out, rock solid now. And let me go ahead and switch back to the my webcam along with the game cam. Again, I'm capturing both audio and gameplay video digitally now. I used to just kind of point a camera at the screen and go for it, you know, but now we do it a little differently. So on the bench, I do have a little remote control here. Let me move this camera a little bit more out of the way. It's encroaching in my space. So I'm going to go ahead and hit the power button, which turns on the transformer. Again, I'm running a full original linear with the bottom transformer from a Williams cab. Nice carpet pattern, which tests the RAM. All systems go, and you can see it comes right into a track mode. It still has some residual credits from me testing here. So that tells us that the battery's good, the CMOS, all the volatile memory's been preserved through the power off. Also on my bench here, I have a PlayStation 2 controller, I think, and I built a little Arduino board, custom board, that can decode the serial inputs from this controller, and then based on that, it'll output and basically close switches and ground the inputs on the I/O board or the ROM board. So I can load configurations to that board and basically map out all of these controls on a PlayStation controller for any game on my bench. So for Joust, I have it mapped a certain way, Robotron, Bubbles, all the different games, and even the analog sticks on here, I'm able to decode those, and I set up for like 49-way joysticks for Blaster and Sinistar and things like that. So it works quite well. I could also just send analog outputs if I needed to, if I was doing some other non-Williams game, which I don't do a lot of. So you can see she's booted up there. Let me go ahead and I will coin it up. Not that there's not already 13 of them on here, but should be getting the audio as well now. My capture card's a little glitchy sounding to me, at least. I'm not sure if it's like that in the video. But, oh boy, that's loud. Yeah, the audio's not great here. It's a little glitchy sounding. Oh boy. I'm going to drop it in diagnostics. So again, anything with the audio here is just on my capture. It's when I plug in an actual speaker, it's fine. So did a ROM test. Now it's going in to do a RAM test. No RAM errors. Then we'll go through and test the CMOS. No CMOS errors. Loop through some sounds here. Let's see if these are better. And then just loop after 6. And then we go in and do some switch testing. Again, I've got the controller so I can do left, right, flap, coin, player 1 start, and then I'll do advance and focus to the next screen. There's the grid lines to set your convergence on the monitor if you're not using a TPG, a test pattern generator, red, solid red, and then green and blue. And then we go through color bars, and then bookkeeping data, and then where you go in and set your configuration, game adjustments, free if you want to enable free play or put a special track message or, allow preset a high score. You can do all that kind of stuff here. And then back to a track mode. So again, this board's good to go. I'm going to get it boxed up. It's ran for probably 30 hours now after I've got that intermittent issue solved. So I'm very confident it'll be reliable. So box it up, get it back to the customer, and looks like the next repair in the queue is actually a pinball, one of those Type 1 soundboards, which is kind of the rectangular one. I did it in another video. Somebody saw the video and it's like, hey, I've got problems with mine. It does have hum. Can I send it in? I'm like, yeah, we'll take care of it. So I may, if I get the bench set up, go through and actually doing the part change out, the troubleshooting a little bit, and also maybe show doing the upgrades where I eliminate that hum by modifying the circuit to match more closely actually what was on here. It's not like I came up with some original fix. Basically, I compared the two schematic layouts between the newer boards with that older Type 1 and saw that there was some, pretty big differences. I did come up with the way to lower the gain though. The gain on these that they have preset on these amplifiers is really high, and it's like a times 100 gain, which is way overkill. So I go and change a resistor in a voltage divider circuit that will reduce that gain to about 60 to 70% increase on it. So any noise that comes through, if the game code sends something the amplitude is too high, it ends up getting clipped, like you hear like in Sinistar where the scream, it sounds real garbled and distorted. That's because they're basically just maxing out the peak on that audio amplifier. So hoping that the fix I came up with there is going to work. I may do another video on just Sinistar for that problem. I've got all the resistors I had ordered, all the parts in stock to do that fix. So anyway, thanks for watching. Appreciate it, and keep an eye out for the next one. Bye now.